to Unit 2 now of Algebra 2. We have 2-1 monomials. We're looking at the product and power rule today. Go ahead and put your name, that top right hand corner, today's date, and remember you can push pause and rewatch this as much as you need to. Now, first things first, we have our objective. Remember, hit pause if I ever go too fast. It says, I am learning to apply the properties of monomial rules. So we're looking at two of those rules today. Product, which if you think back to our order of operations, product is the answer to a multiplication problem. And then power means that we're now going to have exponents. We're going to look at those two type of rules. So now if you look down here, our notes there are set up in a table. So go ahead and take a second, jot down this table. We have three columns. Our first column has the name of the rule, product, and power. Our second column is actually seeing the rule play out, and then our last one is seeing some examples. So hit pause and sketch out this table, and when you're ready, hit play. Alright, for our product rule, we have two main steps. And the first main step is that we're going to multiply coefficients. Oh, my C turned into an O there. Oh, I erased a lot. That's okay. Multiply coefficients. Okay, so we know that product means to multiply, so coefficients always do what they're told. And if you forgot what coefficients were, that's okay. Just remind yourself and make this little note that it's the number in front of variables. We'll talk a lot about coefficients this lesson, so if you need to that refresher, just jot that down. So coefficients are the numbers in front of the variables. So if we're going to multiply the monomials, we're going to multiply the coefficients. The next step is that we're going to add exponents of variables. Of same variables. Forgot my word there. Of same variables. There we go. Those are our two main steps. Step 1, multiply coefficients. Step 2, add the exponents. Now the rule that we're going to see is just kind of how it could look once we plug in numbers. So it's x to the a power times x to the b power. So we have that multiplication happening there. And x is the same variable. He does not have a number in front, so there's no coefficients. So you don't have to worry about multiplying coefficients because there aren't any. And now we're going to say with those exponents, we're going to add them. So it'll be x to the a plus b power. You just add the exponents. Now an example of that is over here. So I'm going to rewrite these bigger just because I know it's itty bitty right now. So we have h to the second power times h to the sixth power. So it's the same way we did that first one over here. We said that they don't have coefficients, there's no numbers in front of our h's. And now because the exponents are 2 and 6, we're going to add those exponents. So 2 plus 6 gives us 8. So it'll be h to the 8th power. And we're good. And real quick, while we're on this example, I always kind of like to show it up here of what it actually means. If you have h squared, that actually means h times h. If you have h to the 6th power, that means there's 6 of them. So h times h times h times h times h times h. If you look at all the h's there that are being multiplied together, you have 1, 2, 3, 4, 5, 6, 7, 8, which gives you h to the 8th power. So it just keeps us from having to write out all those variables. Alright, this next one has negative 2a squared b times 7a to the third b. Alright, so this time we do have coefficients. So we're going to multiply the coefficients, multiply those numbers in front. So negative 2 times 7 will give us negative 14. Oh, I forgot my 1 there. Negative 14. Now we're going to add the exponents of same variable. So I have an a squared here, I have an a to the third here, so we just add on 2 plus 3 gives us 5, so we have a to the 5th. Okay, I think the pen's working again, so I can draw lines under. So we have a b in this parentheses, we have just a b in this parentheses. So it's actually b to the first. So if I have b to the first times a b to the first, we add the 1 and 1, and we get b to the second, because there's actually 2 of them there. So that means that there's 2 b's, and we're good. That's our product rule. Now the second one we're going to look at is the power rule. So for the power rule, our steps for that one, I always like to kind of make a first statement and say, we're going to distribute the power. It's one of the first things we're going to do. So distribute power. Now once we distribute that power, we're going to raise coefficients to that power. So remember, like how we said it, when we're multiplying, we multiply the coefficients. When we're raising them to a power, we raise the coefficient to the power. So coefficients always do what they're told. Now, after we raise the coefficient to the power, we're going to multiply the variables exponent with power. Alright, and we'll see it the same way for like the rule written out here. We'll do ax to the a power being raised to the b power. So if I have x to the a power, that means that's going to be multiplied. So we're going to say a times b, so it's going to be x to the a b power. Now to see it over here for the examples, we start off with x squared being cubed. So because we don't have a coefficient, I should have said that over here too. This one doesn't have a coefficient in front, so you don't have to worry about that first star. No coefficient in front. So now we're just going to multiply those exponents. So multiply the exponent to the power. So we'll just say 2 times 3 will give us 6. So it'll be x to the 6th power. Now one thing I like about this one is to kind of show how it works. If you have x squared to the third power, that actually means x squared times x squared times x squared, because it's being multiplied to itself 3 times. And since we know the rule from before, we can add those exponents. 2 plus 2 plus 2 is 6. And then the really, really long way is to show all the x's you have. So if you have x squared here, oh, I got another extra straight line there, and x squared here, and x squared here. I guess I got all the extra lines there. So all those x's added up for all these individual ones would be 6. So x to the 6th power is much nicer to write than to have to go through all of that. So just multiply those exponents. Now for our second one, we have negative 2 m to the 5th squared times m to the 3rd. This one actually has multiple things going on. I have a monomial being raised to a power and being multiplied. So if you think about order of operations, exponents come before our addition or subtraction or multiplication or division. So we're going to have to raise to a power first. So I'm going to raise the coefficient to the power, so negative 2 squared. So that's going to be negative 2 times negative 2 to give us positive 4. And now we're going to multiply the exponent to the power. So 5 times 2 will give us 10. Now my m to the 3rd just drops down. Now at this step, we've done raising to a power, so that dot there just means multiplication. So now we're going to multiply coefficients. 4 times 1 there would still be 4. And then m, and we're going to add the exponents. 10 plus 3 gives me 13. And we're good. And those are our rules for our product rule and our power rule of monomials.